Hey guys, here we go. I'm going to record this one live on the camera. I'm going to turn on my calculator here and I'm going to show you in the mode button here. When I hit mode, it brings up this menu. This is what I meant by Math Print and Classic. So I'm going to highlight the word classic and I'm going to hit enter. Now when I hit enter, I have to move it down so you can see that. So just trust me, whenever I punch in numbers or something, the more important things are going to be at the top of the calculator, so I want to leave that visible. But here I go. I'm in classic mode now. So if you're using an older calculator or whatever, if you want to follow along and have your screen look just like mine, please do this. So here we go. I'm going to quit that screen. Right above the word mode, it says quit. I'm going to go second mode. So I quit that screen. When you get stuck and you hit, because sometimes you'll finger flub and go, oh crap, what did I just do? You can always quit the screen. That's a good thing. All right. Before I do this problem, you'll see it says find the x-intercepts, leave any radicals in simplest radical form. And they gave me a polynomial, y equals blah, blah, blah. So when you guys get your first assignment to work on these kind of things, the first worksheet's written this practice style. What you're going to do is you're going to set this thing equal to 0. So you're going to say, you know what? I'm going to move that a second. Set it equal to 0. And guess what? I am going to find 3 x-intercepts because it's a third power question. Now, it's in descending order. All the stuff's the way I want it. So I'm going to write down here my coefficients. 1, -3, -4, +12. I'm going to draw my line. I'm going to bring down the 1. By the way, this number is going to be a 1 on these practice problems because I have to show you what happens when it's not a 1. That's not happening to you today. But here we go. Shelf number. So just as promised, oh, you can't see that? I'm going to have to slide it over. Just as promised, for the shelf number for this, I know for a fact it will be something that goes into 12. What goes into 12? 1 goes into 12, 2 goes into 12, so does 3, so does 4, so does 6, so does 12. What I'm showing you right here is based on this last number in my list. It's called the rational roots theorem. We will talk about this more, but it has a name. Why do we look at these numbers only? It's called the rational roots theorem. Rational is a fancy way to say fractional, even though these are all whole numbers. They could all be written over 1, which would make them look like fractions. But rational roots theorem is what I'm teaching right here. This what goes into 12. Now that means I should pick 1, maybe -1, 2, maybe -2 for my shelf number. But how do I know for sure without just guessing? That's where we graph. So here we go. I'm in classic mode. So I'm going to hit y equals. All the buttons up here are for graphing. So I'm going to go y equals. And I'm going to say, here's my x button. Right below the mode key is this x, comma, t, comma, theta, etc. I'm going to hit x. I want to take it to the power of, so I've got to slide this down a little bit. I'm going to take x to the power, that's the caret key right there, to the power of 3, minus, so I'm going to hit the minus button, minus 3, I hit the number 3, x to the second. Let's keep entering. I need minus 4x plus 12. Now I want to make sure, before I hit graph, pause it. Make sure you have the exact same thing entered in, because if we don't have the identical entries, we are not going to match. Now here's the other thing. If you want to use this key down below, this is to make a number negative. This is not the same as saying minus. Be careful. Don't use the wrong key. They look different on the display when you use them, but just for our intents and purposes, see this guy right here? I'm going to hit graph now. What does my picture look like? What is it trying to tell me? Well, hey, we know what a polynomial graph looks like. We know that this is an odd-powered polynomial, degree 3. It goes up on the right. It goes down on the left. Hey, that's what it did in the picture. But take a look. Where did it cross the x-axis? It crossed it at 2. It looks, or wait a minute, that looks like 3, 2, and possibly -2. Now, one thing I did not mention, if your screen or your graph does not look like this, it might be because you did not reset the screen. All the buttons across the top are used for graphing, so I'm going to hit zoom. Zoom will bring up this big long menu. We'll talk about different things in this menu, but right now I want to talk about zoom standard. If your screen doesn't look like mine, you can arrow down and go zoom standard, or you could just hit the number 6 on your pad. That will reset your screen so it looks just like mine. Sometimes somebody will do something with the calculator and mess with what it looks like. That's called the window, by the way. Take a look at that. I'm going to hit this button just once. Window. X-min. On the negative side of the x-axis, I have 10 dashes. That's what that means. X-max. On the positive side of the x-axis, I have 10 dashes. X-school. That just means every dash is worth 1 unit. Y-min. On the downside, on the bottom side of the y-axis, 10 dashes. On the top side, etc., Y scale, everything's worth 1. We'll worry about this stuff in a future thing, no biggie. But in the window, what it tells you is, I'm going to go zoom standard one more time. I can do it as many times as I want. It means if you wanted to count it out, there's 10 dashes here, 10 here, 10 here, 10 here. That is a standard screen. Now, here's the thing with this. I look in my rational roots and I say, you know what? I totally see the number 2. That corresponds with x-intercept at 2. I also see a -2. Looks like it corresponds with that one. And then I also see the number 3. That corresponds with this x-intercept. So guess what? This would be a criminally easy question for me to put on a test. I would never do that because your answers are right there. I'm going to just say, based on this graph, my answers are 2, -2, and 3. Those are my 3 answers for this polynomial equation, or, But let's verify that. When I showed you guys on part A video, I said, hey, when we do synthetic division, we pick different numbers sometimes. So I could pick any of these 3 and make it work out. So let's suppose I chose 2. I'm going to use the number 2. What would I do then? 2 times 1 is 2. I would add down. I'd get -1. 2 times -1, I would get -2. I'd add down. I'd get -6. 2 times -6 is -12. I get 0. Boom, there it is. So yes, indeed, I verified that that is truly an answer. However, I'm not done. I still have to find the other 2 answers. Well, x squared minus x minus 6 equals 0. If I took this now and I factored it, I would have x times x. Whoops, you can't see what I'm doing there. I would have x times x. The last sign's a -6. So to get minus, it has to be opposite signs. I want the middle term to be a -1, so that just forces me to do it this way if I'm going to factor it and set it equal to 0. Therefore, the answer here would be -2, chaw. And here the answer would be 3. I have solved this polynomial equation. Solving a polynomial equation is what allows us to find its x-intercepts. So let's recap, because I want to make this so it flows pretty easy for you. So here we go. Example 1, it was a third power problem that I personally knew was going to end up with 3 whole number answers. I could have gotten all of those answers just by looking at the calculator. I really could have. I won't do that for you on the test. I'll make you work for it. But I use synthetic division, but what it does for me is it incorporates this concept, rational roots theorem, with what my picture looks like to give me a starting location. As long as I can start somewhere, as soon as I get it down to second power, I own it, because once it's at second power, I have all kinds of tricks that I can use to get it solved. So let's look at one where it's not so easy, but I want to show you this because there's so many things you can do up here. Check this out. Right above this button, see if I hit trace, trace is, well, I'll show you. If I hit trace, I get, here's the name of my equation. It says x is 0, y is 12. Guess what? That just means you're starting off on your y-intercept. But I can move with my side-to-side arrows. Whoops. My side-to-side arrows, watch. I can move and you'll see a little blinking guy. That's an estimating dude. It's estimating when x is at 1.36 blah blah, y is equal to 3.5. So it's a point on the graph. This can let me move around the sideways arrow, and I can go the other way too. Now, trace is just for guesstimating. But right above trace it says calculate, right above there, so I'm going to go second function. So I'll go second, trace. Now here's something we will use to make our lives a little bit easier, where it says value. I'm going to go value. Hey, one of the answers I got was obviously 2. If I said x equal 2, it's going to say, guess what? When x is 2, y is equal to 0, meaning that's where you intersect the x-axis. Wow, I could check my answer right away. Let's do that again. Right above trace it says calc, so I go second, calc. Calculate the value at 3, because 3 was another one of my answers. Heck, there it is. 3 is one of my answers. So when I hit enter, hey, y is equal to 3 when x is equal to 0. Que bueno, thumbs up. All right. So let's look at a couple more examples. This, remember, is just an instructional video to help you navigate the calculator with the math. We'll start on Monday, or well, it depends. Sorry, I don't want to say Monday because I might end up using this video again, and it might be a Tuesday for a different class. So let's just say, here's another example. There are no homework questions in this, but I'm going to go now and say, hey, is it in the right order? Yes, it is. Are there any missing powers? No, there are not. If I'm going to do synthetic division, I have a 1, I have a -10, I have a 19, and I have a 20. I'm going to draw a line. I'm going to draw that arrow down. I'm going to bring down the 1. I got to pick a shelf number. What shelf numbers should I use? They should be things that go into 20. So it could be 1, it could be 2, it could be 4, it could be 5, it could be 10, it could be 20. Those are things that go into 20. It could be a positive thing or a negative thing. So these guys right here are called my rational roots, or possible rational roots. The theorem, the word I'm not writing there, is the thing that says, hey, if you look at this number, one of these or maybe several of these are going to work here. There's the key. In my last example, all the numbers that worked were right in that list. That's not always true. The rational roots theorem says if it's gonna work, it comes from this list, but it doesn't mean every single answer that's possible is going to be in this list. In fact, for this particular example, I don't know what numbers work. I am going to now then graph this so I get an idea where to start. So, technically, set it equal to 0 because you're going to find x-intercepts by setting it equal to 0. Make your list, get your choices, go back to y equals, and let's get rid of this. I'm going to clear it out. I'm going to hit the clear button, and let's enter this new problem in. The new problem that I am entering in is x to the third power minus, not negative, not the bottom key, but minus 10x to the second plus 19x plus 20. Now pause the video if you need to. Make sure that you have it entered in exactly as I do. I know that I already had zoom standard, so I'm just going to hit the graph button. And let's see what it's trying to tell me. It's telling me not that much, because I notice it doesn't exactly hit at -1 here. It doesn't. It's close, but it ain't. I could verify that. I could say, well, -1's one of my possibilities. Well, let's go second, calculate the value at -1. And if I punch it in, guess what? It does not say 0 here. It says -10. That's not what I want. Let's go back. I'm going to look at the graph again. Over here, it's 1, 2, 3, 4, 5, 6, 7. I don't even have a 7 in this list. That's shenanigans. I don't know what that guy is. This dude over here, that's crazy. But if I did say, hey, I want to calculate the value when x is equal to 7, it'll tell me when you plug in 7, you will get out 6. That is the ordered pair, 7, 6 right there. That's not where it crosses the x. So guess what? The only intersection value that I see that will help me solve this equation or find the actual answers, the numbers where it crosses the x, looks like 4 is my only choice. So I'm going to try 4 as my shelf number. Before I do that, I could verify that it's correct. I go second, calculate the value at 4. And what does it tell me? It says, you found me, baby. So I go, okay, good. I'm going to now move this out of the way for a little bit, so I have some room. And I'm going to use synthetic division. 4 times 1 is 4. Add down, I get -6. 4 times -6 is -24. Add down, I'm having a brain fart. There it is. Okay, -5. 4 times -5 is -20. Hallelujah, that gives me a 0. Ding, ding, ding. And then I go, yay, I'm only in need of 2 more answers. And this is a classic fake factor. It looks like it's going to factor. You go totally, because 5 times 1, that adds up to 6, blah, blah, blah. But you cannot do it. Here's somebody who's not paying attention. They're just trying to work fast. X times X. Then I go, ooh, I need a 5. So I go, oh, that's easy. I'll go -1, -5. Then I get what? I get my -6. Yeah. So this would be 1, that would be 5. But wait a minute, look at our graph. It doesn't cross at 1, it doesn't cross at 5. That is a what? Oh, well look, -1 times -5 in the FOIL, that would be a +5. That's not what I have. Oh man. So here we go. I don't know about you, but I personally think that this would be a good candidate for the quadratic formula. So I'm going to say -b plus or minus the square root of b squared, so -6 squared is 36, minus 4 times a times c, all over 2a. Then I look at that thing and I go, okay, it appears to me that this will be 6 plus or minus the square root of 56 over 2. Boy, that's an ugly number. It really is. But I can even simplify this. Now, 56 is one of those weird numbers because, you know, it's big, but 4 is the only, it's 4 times 14. Now, how did I know that? I made up the question, but also I know how to play with my calculator. If I wanted to, I'm going to quit this screen. Quit. 56. Well, I know that if I divide it by 4, hey, there's 14. 4 is a perfect square. There are no perfect squares in 14. So I just found that number by playing. I just was playing around. And then what comes out? I take the square root of 4, a 2 comes out. So I end up with 6 plus or minus 2 rad 14 over 2. Do you see what I see? There are 1, 2, 3 external values. You may only reduce one of these answers if all three values have a common factor. So 2 goes into that 3 times. 2 goes into that once. I don't have to write 1 rad 14. I could just write rad 14. And if there's a 1 on the bottom, I don't have to, If there's a 1 on the bottom, I don't have to write it in. I don't want kids at math camp teasing me next summer. So here's my other 2 answers. The other 2 answers. 3 plus that is one of my answers. 3 minus that is the other answer. Now, how many answers do I have total? 1. There's one of them. X equals 4 is where it crossed. 3 plus rad 14 is where it crossed. 3 minus rad 14 is where it crossed. Now, you don't believe me? Check this out. I'm going to go back to my graph. I'm going to hit graph. And I'm going to do this. I'm going to be so bold as to enter second, calculate the value of 3 plus. Now, the root key is right here. Right above x squared, you'll see the root. So the square root of 14, guess what it's going to say? It's going to say 0 because I nailed it. Nailed it. Woo! I could also do second, calculate the value at 3 minus the square root of 14. Are you kidding me? What's it going to say? Oh, it's going to say, you are awesome. How cool is that? How cool is technology? It allows us to all stay safe and still learn. I guess that's how cool it is. Oh boy. So anyway, guys, instructional video. I'm just showing you how to use the calculator, the rational roots theorem, your knowledge of synthetic division techniques, and in this case, hey, this is the first thing I've shown you where it doesn't factor, because Mom always said, not everything factors. Then I use quadratic formula, and that's okay. That's okay too. I got one last problem to show you, so here we go. Let me grab it, because I wanted to show you a 4th power one using this trick. But guess what? This 4th power graph here, 4th power, that means when I graph it, it's going to go up on one side, up on the other side, because it ain't negative. Let's go get this thing ready to go. I also have no gaps. It's in descending order. I could set it equal to 0 right now. I'm going to move this out of my way, and I'm going to say the 1, -6, 4, 15, and 4. I'm going to bring down the 1. I'm going to use a backwards L called a shelf to list my possible choices, which come from here. My possible choices will be plus or minus 1. What else goes into 4? 2, and then 4. Hey, that looks good, 1, 2, and 4. But I don't know which one of those to choose, so let's graph it. Let's take a look at the graph. So I'm going to go back to y equals. I am going to clear all this junk out. I am now going to use my buttons and punch in x to the 4th, menos 6 x a la tercera, más 4 x a la segunda. I'm not going to do this in Spanish forever. Plus 15x más 4. Okay. Make sure you have it entered in like I do. Pause the video if you have to. Remember, pause me anytime you need to. Okay, let's hit the graph button. What you doing? Come on, baby. There it is. Oh my gosh. Oh, there's 4x intercepts. But of those 4x intercepts, this one right here looks like -1. That's part of my choices. This does not look like 1, 2, or 4. That one looks like shenanigans. Over here, that's kind of like 3, but I don't kind of have like 3 in here at all. But I do have a 4. So my guess, here's my guess, based on this picture, I'm guessing that if I was going to do synthetic division, right now, I would choose -1 as one of my choices and 4 as one of my choices. In fact, I can do second, calculate the value at -1. And look, -1 is totally a good choice. I could do second, calculate the value at 4. And I could say, whoa, totally a good choice. Totally a good choice. So guess what? I already know two of my solutions. I know exactly where two of those x-intercepts are. One of them's at -1, the other one's at 4. So it doesn't matter which number I start with over here. I'm going to start with -1. What the heck? So I'm going to do -1 times 1. That's -1. Add down, I get -7. -1 times -7 is 7. Add down, I get 11. -1 times 11 is -11. Add down, I get 4. Cha-ching. Oh yeah, sweet. So I did verify. That is one of my answers. Now, I'm going to draw a line again because since it was a 4th power problem, I got to do synthetic division one more time. Here's my shelf number. I'm going to use 4. Why? Because that's what my calculator told me to do. 1 times 4 is 4. Add down, it's -3. 4 times -3, -12. Add down -1. Ding, ding. It looks like, woo, I'm a winner again. Dos veces, I am a winner. Soy ganador. So I'm going to do this, right? Because I got it down to 2nd power. Once I get it down to 2nd power, I own it. Now, I'm going to use quadratic formula to do this and say, I'm going to give myself some room here. The result of this will give me the remaining 2 answers. That'll give me a grand total of 4 answers, and I will then be done. So I'm going to say -b plus or minus square root of b squared, because -3 times itself is 9, minus 4ac all over 2a, or 2a. 2 times 1, 2a. So I get 3 plus or minus the square root of. Now this guy is just 9 minus -4, or the whole total in there, 13 it looks like. Now, guys, this part right here is called the discriminant. If I had $1 for every time a kid punched this in incorrectly, I would have so many dollars. I don't know. I would count it all up, but I'm not really good with numbers. Get it? That's a joke. Anyway, so we go like this. I'm going to enter it in on my calculator. If I do, I go 9, what is it? 9 minus 4. I'm just going to type it in exactly how it's written. -1, not -1, -1. See, look, the beauty of these calculators, even the other ones, even the TI-83s and stuff, they do the order of operations for you if you write it just like that. Watch, check it out. Bam, 13. Let the calculator help you sometimes. That is beauty in motion. So, what do we have? 3 plus or minus 13 over 2. Now, if I want to check this answer, I'm going to walk you through this. Remember, that represents 2 answers. I'm going to go back to my graph. Let's plug in this one, 3 plus rad 13 divided by 2. But I'm going to show you this is going to do it wrong. Let me show you the wrong way. Second calc value. And I say unto the calculator, 3 plus the square root of 13 divided by 2. And it's totally going to not be right. What? That's crazy. Let me show you why it's not right. Second calc value. All calculators have one single fatal flaw. They do not understand how to divide more than one number by one number at a time. So you have to tell your calculator, I am going to check this answer first. Whoops, I wrote it and you can't see it. I am going to check this answer first. Notice I had to put this in parentheses. Now the other thing about classic mode versus math print mode is when you use classic mode, it automatically puts a parenthesis there, so I'm going to have to put one there. Whenever you got a parenthesis going this way, you need one going that way in math for your calculator, or it confuses it. Sometimes it gets it right on accident, and sometimes it doesn't. But let's verify it. So here we go. I'm going to punch this thing into my calculator. Second, calculate the value. And I'm going to go parenthesis. 3 plus the square root of 13. I'm going to close the parenthesis for the radical. I'm going to close the parenthesis for the top of the fraction, divided by 2. And then I'm hoping it doesn't do anything weird. It did the weird thing. Now, here's the one thing about calculators. They do not know how to think. They only know how to do what they know. Whenever your calculator does this, what did it tell me? It says, right there it says, 4e negative 12. Whenever you see your calculator go, E, like a monkey, E, whenever it does that, it means 4 times 10 to the negative 12th, which you guys would know as scientific notation. That is an extremely tiny number. So guess what? This is your calculator trying to say 0, but it doesn't know how to pronounce the word 0. So guess what? That number right there is the decimal equivalent of that when I plugged it in. But look, see where it's blinking? It's right on the x-axis. That is an x-intercept. Now, the nice thing about it is, if I check this answer, it guarantees that this answer would have also been correct. This answer would have also been correct. One thing you're going to realize, whenever you have root answers, they're always two-part answers. 3 plus rad 13 over 2 guarantees that 3 minus rad 13 over 2 is going to be your other answer. So all you have to do is pick between the two of them, which one's easier for you to punch into the calculator, and you do it. But remember, if you punch this into the calc, you got to lock that up, you got to lock that up. And if you're in classic mode, you're going to lock that up and lock that up. If you don't, it will lie to you every time. How do people usually lose points on tests and stuff? Careless stuff like that, okay? So anyway, that is me verifying the answer. So I had 1, I had 1, 2, 3, 4 x-intercepts for that problem. Okay, I'm dropping the mic. What? Anyway. That is part B. That'll totally get you home on Monday. I keep saying Monday. It might not be Monday if I'm using this video again later, so I'm going to stop doing that. So the next lesson is video 7. You're going to see just a couple examples, and then you guys practice. And then I believe it's video 8 without looking at everything. And you'll see the last part of this. Then we're done with this unit. Okay. You should have seen this video before we start next week. Okay, bye-bye, guys. Have a good one.